As we said, the LF is a rigidly ordered string with a universal order, asterisk. Sort of basic form of this: C, polarity, tense, aspects, verb, objects, adverb, subject. Now, obviously, this is a sort of shorthand for, we probably need lots more adverb positions following Chingue's work. And there's also going to be at least some language particular variation here. So for example, in English, things like perfect and progressive will have multiple exponents, like have and for perfect, being for progressive. Other languages might not realize certain categories and so on. But the overall order of the categories, if they're present, is the same. So an immediate consequence of this sort of ordering for the clause structure is all the major cases in the clause of the final-over-final condition, which is usually expressed as something like, star, beta, gamma phrase, alpha. The idea being you can't have a head initial complement of a head final phrase. Right? In our terms, this would be alpha would be the first head, then beta, then gamma phrase. So this is the star 2-3-1 condition in action. There's a classic illustration from Finnish, which allows both prepositions and postpositions. And when here you have a preposition, a noun with a prepositional complement. This obeys FOFC, the final-over-final condition, and is grammatical in the language. Having the outermost preposition at the end then has a head initial complement. This runs afoul of FOFC and is in fact ungrammatical in Finnish. And yeah, there are a number of these very robustly verified across languages. You can't have verb object auxiliary order, verb object complementizer. If you have a complement clause to a verb, it can't be complementizer initial. This NOP, this is supposed to be the object of the noun. So this is what we were seeing in the Finnish example just above. You can't have polarity at the beginning and C at the end within the same clause and so on. Again, these are all instances of this 2-3-1 condition where obviously we're talking about the sort of relative position in the hierarchy. So 7-8-4 is a 2-3-1 contour in these terms. And a first thing to point out is that this 2-3-1 avoidance condition is very restrictive, especially as we get longer and longer strings. So what we see in 13 here is, for the number of elements n down this column, the number of 2-3-1 avoiding orders is the numbers in this column. These are the so-called Catalan numbers. And they grow much more slowly than n factorial, which counts the number of logically possible orders. And the thing to look at here is really the proportion of 2-3-1 avoiding orders to possible orders in this column. Right, we've seen the case already of 3 elements. We get 5 of the logically possible 6 orders, everything except 2-3-1. 14 of 24 with 4 elements. This is the universal 20 case of noun, adjective, numeral, demonstrative. Chingue 2005 reports 14 of these orders are tested, a little more than half. But as we get to say, 9 or 10 elements, we're down to 1% or less of possible orders actually fit this condition. By the time we have 15 elements, 1 order in 100,000 actually obeys this condition. So the longer it is, the more restrictive. And this is very informative if you're a child trying to discover the structure of your language, especially if there is some variation in word order. Might also be useful for building software to automatically discover language structure and so on. Okay, with that in hand, let's go ahead and work through an example here. So this example in English, they haven't been eating cake. And the lines I've drawn here crossing indicate the famous affix-hopping pattern in English, where the have and the n are the 2 pieces that make up the meaning of perfect, and be and ing together mean progressive. The other categories are as indicated here. So I indicate, FX is the affix associated with the auxiliary with the same index. S and O here are thematic subject and object. In other words, external argument, internal argument. Okay, so here we go. This is the tree we get in this theory for this example sentence. They haven't been eating cake. So the way this works is to get the word order, we traverse in pre-order, which is left to right in the tree and top down. So we start at the top and go down the left. So they have tea and to be and eating cake. That is indeed the word order. Going through the same tree now in a different order, post order, which is still left to right, but now bottom up. We get a different sequence, tea, have, and being, eat, cake, they, which, looking at the categories, fits the hierarchical format we had specified above. treating neg here as an instance of the polarity head. And now from this, we get this LF string. What do we do with that? That is read by the LF grammar, the LF PSG, which builds this structure from it, which should look pretty familiar, right? This is CP, neg P, etc. One thing different here is that all of the phrasal stuff, including arguments, is all on the right, so rightward specifiers. Another thing to note here is that at LF, the pieces of perfect and of progressive are adjacent at LF. So this is a kind of multiple exponents rule of English, very similar to Chomsky's 1957 analysis of affix-hopping, where have n comes as one unit from the lexicon, and then a transformation hops the n onto the next verbal element over. Obviously a different mechanism here, but the same analysis of what's going on at LF, that these are the pieces of perfect and progressive.